Hello and welcome to another NGen Math 6 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 6, Lesson 4 on messy equations. So all throughout Math 6 we're going to be solving quite a few one-step equations. That simply means you need to do one arithmetic operation, one addition, one subtraction, one multiplication, one division, just one thing in order to get the variable all by itself. And we've now worked with those kind of equations for a couple lessons. Today, all we're simply going to do is more of those types of equations, but that are a little messy, that involve fractions or decimals or something to that effect, right? So let's get into them right away with a review problem on non-messy equations, and then we'll segue to some that aren't so nice. Let's get into those now. All right, so a review of all one-step equations. Let's take a look at exercise number 1. Solve each of the following one-step equations. Show your work. All right, awesome. So literally, these 4 equations go through all 4 of the different types of sort of equation solving techniques that we've seen so far. So let's go through them all together. All right, so in the first problem, right, where we have x plus 8 is equal to 19, we have to undo that addition of 8 by subtracting 8 from both sides. Literally, we do the opposite of what's been done to the variable, and we find that our solution to the equation is x equals 11. I want to keep coming back to and emphasizing the fact that you can easily check to see that this is a solution by taking 11, putting it back into this equation and saying, is 11 plus 8 equal to 19? Yes, it is. And again, that's critical because it would be easy to look at this equation and think, oh, maybe I should add 8 to both sides. X is equal to 27. But then if you were to put 27 into the equation, you'd find, 27 plus 8 is not 19. Anyway, let's keep going, right? So for letter B, we have n minus 7 is equal to 2. I want to do the opposite of what's been done to the variable. Since I've subtracted 7, I'm going to then add 7 to both sides of this equation. That subtraction and addition by 7 cancel, and I end up getting n is equal to 9. All right. Letter C, I've got 5 times c equals 15. Right? In order to solve this, I need to undo the multiplication of the c by 5 by dividing both sides by 5. 15 divided by 5 is 3, so c is equal to 3. And finally, in the last equation, I have y divided by 3 is equal to 8. So to undo that division by 3, I'm going to multiply both sides of this equation by 3. That division and multiplication cancel each other out. 8 times 3 is 24. Now, one of the issues with solving equations where the answers all come out to be nice whole numbers is that they're relatively easy to do in your head, right? I mean, even if you consider like an equation like letter B, I'm looking for a number that when I subtract 7 gives me 2. Well, that's easy enough to think, okay, it's going to be 9. Likewise, hey, I'm looking for a number that when I multiply 5 by that number, I get 15. Well, that number is 3. But honestly, it's the messy equations where this kind of stuff can help us out. So let's start to jump into those in the next exercise. All right, equation solving can involve fractions and decimals. Let's play around with this idea. Exercise number 2. Solve each of the following equations, show your work. Now again, let's take a look at each one of these, all right, and kind of demystify them, okay, because there's a lot of fractions, but ultimately, right, letter A, I've got x plus a number equals a number, right? So this is really no different than x plus 5 equals 7, except for the numbers are more obnoxious. Same thing in letter B, I've got n minus a number equals a number. No different than n minus 5 equals 11, except I'm subtracting 4/5 and it's equal to 1/2. And then the one that's particularly ugly, c plus a number equals another number. Again, these two numbers are a bit ugly because they're both mixed numbers and it's going to be kind of, annoying to deal with. And yet, it's still the same idea, right? So for letter A, if I've got x plus 2/3 is equal to 7/2, then in order to solve this problem, or solve this equation, I'm going to need to subtract 2/3 from both sides. Now, that's where it becomes kind of annoying, because I'm going to have 7/2 with a red fraction bar. 7/2 minus 2/3, right? So I need to get a common denominator. Maybe I'll do that below here. That common denominator is going to be 6, right? And that's going to be 21/6 minus 4/6 will be 17/6. Now I suppose we could leave the answer that way because the problem doesn't specify that our answer has to be written as a mixed number. But if I wanted to write it as a mixed number, that would be 2 and 5/6. Well, that leaves me almost no room for the next set of problems. All right, so ultimately speaking, right, this really isn't any different than if I had something like x plus 5 equals 11. The difference is, if there is one at all, that the subtraction is harder, right? Because it involves fractions, and therefore we have to do a little more work, and it's a little bit more prone to mistakes. It's also a lot harder to check, right? If I took my 17/6, I could certainly substitute it back into this problem, but it would be harder to deal with, right? Same thing for letter B and letter C. So what I'd like you to do, pause the video now, remember your fraction work, and you should be able to get through these two problems with no problem at all. All right, pause the video now and take a shot at it. All right, well, let's take a look at letter B. I'm going to move this down a little bit out of the way. So we've got n minus 4/5 is equal to 1/2. I'm going to add a 4/5 to both sides because I need to undo subtracting that 4/5. All right. On this side then I'm going to have n and n alone, and that's going to be equal to 1/2 plus 4/5. Just like before, we're going to have to get a common denominator, which in this case is tenths, right? So 1/2 can be rewritten as 5/10. 4/5 can be written as 8/10, and when I add them together, we get 13/10, which again is probably an okay way to leave your final answer. But if we wanted it in mixed number form, it would be 1 and 3/10. All right. And finally, the one that probably looks the worst, C plus 2 and 1/3 equals 5 and 5/6. Again, right, in theory, the only thing that's different on this one is that the numbers are a bit uglier, right? So I'm going to subtract 2 and 1/3 from both sides, right? So C is equal to 5 and 5/6 minus 2 and 1/3. You can actually do this subtraction in many different ways. One way I like doing it is just thinking to myself, well, 5 minus 2 is 3, and 5/6 minus 1/3, 1/3 is 2/6, so 5/6 minus 2/6 is 3/6. So my answer here is 3 and 1/2. Now, that's one way to do this problem. Another way to do this problem is to literally change the 5 and 5/6 into an improper fraction, which would be 35/6. Change the 2 and 1/3 into an improper fraction, which would be 7/3. Get common denominators for both, which would be 6. Subtract with the common denominators, etc., etc. But ultimately, you'd still get 3 and 1/2. All right, so again, it's not that this changes anything that we've been doing. It's just harder because of the types of numbers we're dealing with. Whole numbers are awesome. Fractions are, it is what it is. Let's keep going. All right, so exercise number 3. Solve each of the following equations, show your work. Now, this is actually a really important exercise. So we're gonna take our time on letter A and letter B, all right, and really try to understand how we should do this. Now, ultimately, what we've got here is we've got a number times the variable equals another number. So in theory, right, let's say I had, forget about this just for a second. If I had 3x is equal to 21, right? Then it's very straightforward. I should solve this equation by dividing both sides by 3, and I'd get x equals 7. But if you notice, in each one of these cases, the number that's multiplying the variables is a fraction. And dividing by a fraction is, of course, a little bit uglier, but we know how to do it. In fact, we learned how to do it in this course. Remember that when you divide by a fraction, it's the same as multiplying by the flip, or the reciprocal of the fraction, right? So when I look at this particular problem, 1/3 times x equals 10, Well, really, I should be saying to myself, all right, I'm going to divide both sides by 1/3. Now, I don't know about anybody else, but this looks horrible. But literally, this just means 10 divided by 1/3. Now, as we know, 10 divided by 1/3 is the same as 10 times 3/1, or just 3, and so x is equal to 30. Now, all right, let's pause for a second. Number one, that should make sense. If I take 1/3 times 30, I get 10, right? It'd be easy to maybe think the answer to this problem should be 10/3 or something like that, because I got 10 divided by 1/3, 10/3. No, 10/3 is actually 10 divided by 3, not 10 divided by 1/3. So the answer 30 here should make a lot of sense. 1/3 times 30 equals 10, absolutely. But here's what I really want you to see, and then I want to use it in letter B and letter C. I don't really want to divide it by 4/5 or by 2/3. It's just kind of obnoxious. It's kind of ugly. In fact, what I could have done to solve this equation, and I'm going to actually kind of get rid of all of this for a minute, all right, is I could have done the following. And this is the way I'd like to do this from now on. Instead of dividing both sides by 1/3, what I'm going to do to both sides to isolate the x is I'm going to multiply by 3, all right? And the reason I'm going to multiply by 3 is that literally 3, which is the same as 3/1, 3 and 1/3 cancel each other, leaving me with just 1x, right? And that gives me 30, right? So our urge, very understandably, is to divide both sides of the equation by the number that's multiplying x. And that certainly will work. It's just that dividing by a fraction is a bit obnoxious. We can actually isolate the variable in both cases by multiplying both sides of the equation by the reciprocal of this fraction. Let's do it together in letter B. So if I have 4/5 times n is equal to 16, you could certainly divide both sides by 4/5. But dividing by 4/5 is the same as multiplying by 5/4. Okay, and it works great, because if I multiply this side by 5/4, then 4 down here will cancel 4 up here, 5 down here will cancel 5 up here, and we'll just be left with n. Here, of course, I can do this by canceling a 4 into a 16 and getting 4, and then 4 times 5 leaves me with my solution, which is 20. All right? So, again, feel free, divide both sides by 4/5. It's just that when you do 16 divided by 4/5, it will become the same thing as 16 times 5/4. So it's kind of nice to just start that way from the beginning. See if you can do this to solve letter C. All right, let's go through it. So, right, we've got 2/3 times y is equal to 8/15. Again, I could divide both sides by 2/3, but dividing by 2/3 is the same as multiplying by its reciprocal, 3/2. And here I can kind of see that cancellation really easily. Now I need to multiply 8/15 by 3/2. I can do some cross-canceling here very nicely. And I find 4 times 1 and 5 times 1, y equals 4/5. All right, so this is kind of a very special subcase. When I have a fraction multiplying a variable equals another number, I can isolate the variable by multiplying both sides of the equation by the reciprocal, or if you will, the flip of the fraction, right? Reciprocal is the technical name, but in that whole stay, change, flip, or keep, change, change, or however you have it, you think about taking the fraction and flipping it. All right, let's keep going with messy equations. Okay, exercise number 4. Solve each of the following equations, show your work. Well, these are actually going to be a bit nicer than the last ones we did, because again, in each case here, we've got a variable divided by a whole number, n divided by 6, c divided by 10, x divided by 18. Just like in the previous lessons, all we need to do to undo the division by these whole numbers is multiply both sides of the equation by those whole numbers. So, for instance, if we've got n divided by 6 is equal to 7/3, I need to multiply both sides by 6. Whoops, there it goes. Those 6's cancel. I now need to find 7/3 of 6, so I could do a cross cancellation there. 7 times 2 is 14, and n is 14. So that's actually quite nice and quite similar to what we did in the last lesson. Why don't you take a moment and solve b and c for their variables. All right, now both of these didn't come out so nice, right? But that's okay, right? We can handle fractions. C divided by 10 is equal to 15ths. We will multiply both sides by 10. And if it helps you to think about it, you can always put that 10 over 1. I know that does help a lot of students keep track of what's in the numerator and what's in the denominator. Here we can do some cross-canceling of 5s. Then we get 2 times 2 is 4, 3 times 1 is 3, and our answer is 4/3, or if you like, 1 1/3. All right. Finally, letter C, same song, third verse, right? We've got x divided by 18 equals 7/12. We're going to multiply both sides by 18. Again, if it helps you, write 18 over 1 just to keep track of numerators versus denominators. On this right-hand side, we can cancel a 6 from both of those. It'll be a 3, here it'll be a 2. 7 times 3 is 21, 2 times 1 is 2. So we could leave it as 21 halves, or in mixed number form, 10 1/2. Okay, easy enough. Fractions are just numbers, right? But they're not whole numbers, so they're harder to think about, right? And they're harder to deal with, especially when it comes to adding and subtracting them, right? Because then we got to get those darn common denominators, which then we have to work with and we have to think about and reduce and simplify and all sorts of things, okay? But the actual equation solving techniques are still exactly the same as what we've seen in the last couple lessons. Let's now work a little bit with decimals. Okay? Now decimals are the same thing, right? Decimals make the calculations more difficult, but the algebra remains the same. Let's take a look at exercise number 5. Solve each of the following equations, show your work. All right, so again, let's boil it down, right? This equation, x minus 4.6 equals 1.8, is no different than x minus 4 equals 2. The difference is, of course, that we have to deal with decimals. Same thing here, n plus 3.14 equals 7.21, really no different than n plus 3 equals 7. We've just got to deal with the decimals, all right? Still, in letter A, right, since we are subtracting 4.6 from x to begin with, in order to undo that subtraction, we have to add a 4.6 to both sides. And that subtraction and addition cancels as it has been doing, and now we just have to deal with this, right? But we can find that x is 6.4. 1.8 plus 4.6. Why don't you pause the video now and solve letter B for the variable n. This is where you gotta love scrap paper, right? Or at least enough room to show your work. Because again, here we have n, we've added 3.14, nice number, I like 3.14. And we're just gonna subtract it. We're gonna subtract 3.14 from both sides. And now this just really becomes a decimal subtraction problem, right? We can do a little bit of that, 0, and we get 4.07. All right. Not an exciting problem, right? Really, it just boils down to, can you subtract and add decimals together? But that's it. That's all you have to do. Now, of course, you know what's coming. which is going to be the multiplication and the division. So let's keep working with those. Exercise number 6. Solve each of the following equations, show your work. All right, so again, here I've got a number times a variable equals a number. I need to divide both sides by that 7.4. But that's it, right? So, again, no difference than if I had 7n equals, 56. I've now got 7.4 times n equals 50.32. To get rid of multiplication by 7.4, I need to divide both sides by 7.4. Those two will cancel. And now, of course, the hard part is dividing, right? 50.32 by 7.4, right? Now, we learned how to divide decimals this year, all right? And in fact, I really don't want to divide by 7.4. I want to divide by 74. So I'm going to move the decimal places 1 unit to the right in both cases, right? Just a little review of decimal division, right? So I can change this by moving that decimal place 1 to the right and that decimal place 1 to the right. So that I'm doing this. Now I just got to do the division. So I have to think about how many times does 74 go into 503. And I've worked out the problem before, so I'm pretty sure 6 is the right answer here. Then 6 times 4 is 24, carry the 2. 6 times 7 is 42, plus another 2 is 44. Yep, that's kind of nice, 444. Now I have to do the subtraction. That's 49 and 13, and then that's going to be a 9 and a 5. Drop the 2 down, right? This is just long division, everybody's favorite. So now I have to think about how many times 74 goes into 592. Pretty sure it's 8, but let me check. 8 times 4 is 32. Carry the 3. 8 times 7 is 56, plus another 3 is 59. Subtract and get 0. So after all is said and done, right, n is 6.8. That's it, right? And what is the hard part of this problem? The hard part is not knowing that you have to divide both sides by 7.4. That's not the hard part. The hard part is, of course, actually carrying out the division. All right, let's take a look at letter B. In letter B, we're taking the variable t, we're dividing by 24, and we're getting 0.57. So, in order to get the t all by itself, I need to multiply both sides of the equation by 24. Right? So, exactly what we've been doing. Right? I've got t divided by 24 is equal to 0.57. I'm going to multiply this side by 24 and this side by 24. Those are going to cancel. And of course, now comes the hard part. We actually have to do 24 times 0.57. All right, so let's see. 7 times 4 is 28. 7 times 2 is 14, and another 2 is 16. Then we'll index it with the 0. 5 times 4 is 20. Carry the 2. There's already a 2 sitting there, so whatever. 5 times 2 is 10, plus another 2 is 12. Add them all up, 8, 6, 3, 1. We've got 2 decimal places, so t is 13.68. Again, there really is nothing difficult about the algebra. The algebra just says, hey, I know I was dividing t by 24, so I have to multiply by 24 on both sides. The harder part is actually doing the decimal multiplication. At least it's better than the decimal division. Okay, let's take a look at one last problem, and a nice applied problem, exercise number 7. Simon signed up for a new ebook service. The service charges a set price per download. Simon downloaded 12 books and paid $40.20. Let P be the price of a single download. Set up an equation involving P and solve it for the price of a single download. All right, so let's underline all the relevant information, right? I've got 12 books. I'm going to pay a total of this amount of money. I'm trying to figure out the price of a single book. Now, again, think about like if you knew the price of the single book. If you knew that and you wanted to know the total, you'd take the 12 books, you'd multiply it by the price per book, and that would tell you the total. In this situation, what we have is we're going to have 12, right, times the price of the book must be equal to $40 right? That really is modeling what's going on here. 12 books times the price per book is equal to the total amount spent. Now, to solve this, we can simply divide both sides by 12. And that will give us the price of a single book, which maybe over here on the side of our paper, we do $40.20. We divide by 12. We say, all right, 12 goes into 40 3 times. That's 36. Subtract. We'd get 4, right? Drop the 2. 12 goes into 42, also 3 times. That's going to be 36. Subtract. That's going to be 6. Now I need to drop the 0. 12 goes into 65 times. That's 60. Subtract. Remainder of 0. So P equals $3.35. It costs $3.35. Maybe I'll put the dollar symbol there per book. All right. And again, I get it. You know, you could easily say, well, look, if I know the total amount, and I know I bought 12 books, then I'm going to divide the total by 12 to get my price per book. I get it. But again, what we want to see is how the algebra and sort of the arithmetic follow each other. All right, let's wrap this up. So all throughout our equation solving, what we've seen is we've always done the opposite to whatever has been done to the variable in order to get the variable all by itself, known as isolating the variable. Now, in this particular lesson, we dealt with numbers that were not whole numbers. They were messy, they were fractions, they were decimals. And really, maybe the only new thing we introduced were these equations when we had a fraction multiplying the variable equals another number, and we multiplied both sides of the equation by the reciprocal of the fraction. The fraction after it's been flipped, the numerator and denominator have been switched. That's just an easier way. Instead of dividing both sides by the fraction, you multiply both sides by the reciprocal of the fraction. Anyway, that was kind of wordy. Regardless, we have to be ready for equations that have nice numbers in them, but also ones that have messy numbers like decimals and fractions. For now, I just want to thank you for joining me for another NGen Math 6 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.